How's it going, you guys? In this video, I'm going to be talking about section 5.5, multiple angle identities. I'm going to be referring to this sheet a lot. These ones on top here, this is the very top of your sheet, these are your double angles. Cool, double angles, because notice all of your angles are being doubled times 2, times 2, times 2. The ones at the bottom, you can probably guess what they're called. If your angle is being divided by 2, well, that would be the half angles. Right, so I'm going to be referring to the sheet and everything that we are going to be solving today. Alright, here we go. With this one, this is asking us to find sine of 2 theta, cosine 2 theta, and tangent of 2 theta. So I'm going to use my double angle identities 3 times for all of those 3 different ones. So it gives me, says find these on the given interval. I have the interval between 180 degrees and 270 degrees. Well, that is going to happen on your unit circle in this quadrant because that is between 180 and 270 degrees. So when I draw my angle, I'm going to draw it in that quadrant, make a triangle to my x-axis. There's my reference angle. Tangent is opposite over adjacent, so I have opposite over adjacent. Pythagorean theorem will tell us that the hypotenuse is 17. Now, with both of these, notice you went to the left 15, so that is negative 15, and you went down 8, so that is negative 8. And then we can use our identities to calculate from there. So for the sine 2x part, I have sine of 2x is equal to 2 sine x cosine x, so sine 2x is equal to 2 sine x cosine x. In this case, notice I have theta, so what I'm going to do is say that this is 2 sine theta cosine theta. Now I can evaluate sine of theta. This 2 is just going to stay out front. Sine of theta is opposite over hypotenuse, so negative 8, that's not 8 over 17. And cosine of theta is adjacent over hypotenuse, so negative 15 over 17. And then it's just a matter of multiplying these together. Don't remember how to multiply fractions? Go back to 5th grade. So you have 8 times 15, we got 30 times 4, 120 times 2, 240 over 289. Negative times a negative is a positive, so that is sine of 2 theta is equal to 240 over 289. Cool. So I'm going to do the same thing. With cosine 2 theta, notice you have any 3 of these that you can use. I like the bottom one just because I know I'll have common denominators already. But depending on our situation may change which one of these we choose to pick. But I like the bottom one. So with that, finding cosine 2 theta, do it right there. I know I can use cosine squared minus sine squared. Right. Okay, and then cosine squared. Cosine is still negative 15 over 17. Since my cosine is squared, my answer will also be squared. Minus sine squared is negative 8 over 17 squared. 15 squared is 225 over 289 minus 64 over 289. They have common denominators already, which is awesome. So I can just subtract these and say 225 minus 64 is 161 over 289. And there is cosine of 2 theta. Alrighty. And for tangent 2 theta, again, that's the identity down there at the bottom. So this is 2 tan theta over 1 minus tangent squared theta. Alrighty, and then evaluate those where they are. So 2 tan theta is 8 over 15 all over 1 minus 8 over 15 squared. So this will be 16 over 15 all over 1 minus 64 over 225. If you leave it for me like this and free response, I'll be happy. But if you have multiple choice, it will go further. So you can get common denominators. This can be 225 over 225. oops. So 225 minus 64 is still 161, I believe. So I have 161 over 225 on the bottom. And I can flip it and multiply. And this will be 15, 16 times 15, 15 to 50 over 161. And there we go. There's tangent of 2 theta. Yay. All right, in this example, we're going to be doing pretty much the same thing. The only difference here is we're going to be finding tangent of theta, but we are given an interval. So if I can go between pi over 2 and pi, that would be in my second quadrant. Second quadrant. There's my angle. I have my reference angle. I can draw a triangle. Yay, I'll make a song about that someday. So I have opposite over adjacent. So I have 2. I have 3. Since this is negative, this must be the negative 1 since it went to the left in the x direction. Then that will tell us that, well, Pythagorean theorem will allow us to calculate that 4 plus 9 is 13. So this is square root of 13. And then I can do tangent of 2 theta. Yay! It's a crowd pleaser. Well, wait, I was looking at the wrong one. Never mind. Ignore me. But don't ignore me. Listen to me. Yeah, what he said. All right, there's our identity for it. So if I substitute in what I know tangent theta is, well, hey, I didn't even have to draw a triangle, but cool. I can say it's negative 2/3, so I have 2 times negative 2 over 3, all over 1 minus negative 2/3 squared. Yay. And then it's from just their simple calculations. Negative 4/3 over 1 minus 4/9. My common denominator on there on the bottom would be 9. So I have 9 over 9 minus 4 over 9. So that'll give me 5 over 9 on the bottom. So I have negative 4/3 over 5 over 9. And then I can multiply by the reciprocal. 9/5. 9/5. That will cross reduce. 9 divided by 3 is 3. So I have negative 4 times 3 is negative 12. Over 5 times 1 is 5. Yay! Alright, in this example we are going to be solving. Yes, because it says solve. So don't forget that's just like what we had in 5.3 where we would have theta equals pi over whatever, or 0 pi, or things like that. We're going to be coming up with angles. So I can't really do anything with this. I can't factor out a cosine because that's a double angle identity. But since I know that that's a double angle identity, I can choose any one of my identities on my identity sheet because I'm a smart man and I thought about my identity sheet that I've given to on test and quiz. Yay! So remember with cosine, you can use any one of these three. It doesn't make a difference. In this case, I'm substituting on this side. So what I would have left in my equation is whatever I substitute over here on the left side, and then I would have a cosine on the right side. So if I substitute 1 minus 2 sine squared, then I would have to change things so that I would have it all in terms of cosine. Same thing, that one has a sine involved, but this middle one right here, this does not have a sine or anything involved, so I can keep it in terms of cosine. So I'm going to go ahead and substitute that middle one such that I have 2 cosine squared minus 1 equals the other side. All right, all I did, substituted the middle one. Cosine of 2x equals 2 cosine squared minus 1. So 2 cosine of 2x equals 2 cosine theta squared minus 1. Hey, what you gonna say? Bananas in the day. I don't know. There's something wrong with me. So then if I subtract the cosine over, then hey-oh, it's exactly like a problem that you saw in your 5.3 quiz, if we have the same quiz still as the time that I'm making this video. Which you guys do right now. But do you? Future Pike, what are you doing to yourself? Do-do-do-do. We can factor. If you don't know what factor means, then I'm worried. I'm worried for you, 'cause you can't factor. Do-do-do-do. Cosine theta equals -1/2. Cosine theta equals 1. And if you can't do this stuff, make sure you go back and look at 4.3. Unit circle. Hey! Because that's all I'm getting my angles. Cosine is negative NASTC. So it's negative right there, right there. My favorite angle is going to be pi over 3. Pi over 3. Pi over 3. Oh yeah, pi over 3. They don't know what's wrong with me. I went in for a CAT scan, and they couldn't tell me when. I went crazy. Yeah, answers. I like this one. It looks complex, but it's really simple. So, those terms are in common, yeah? Yeah. So I can factor them out and say tangent of 2 thetas times 1 minus tangent squared equals 2. Sweet. And then the only thing I can do here is, we couldn't, never mind. This is our double angle identity for tangent. So if I substitute what I know tangent to be, tangent of 2x is 2 tan x over 1 minus tangent squared. Whoa, look, that's being divided. Isn't that kind of like the same thing? It's going to go away. But let's go ahead and do it. Do it, brah. So 2 tan theta, just copying my identity here, over 1 minus tangent squared theta times 1 minus tangent squared theta equals 2. Well, I do believe that 1 minus tangent squared divided by 1 minus tangent squared makes 1. So we have 2 tan theta equals 2. Whoa, that's a super simple problem now, Pike. So then tan theta equals 1. Whoa, because you divided by 2, right? Yeah, divided by 2. Hey. Theta, first and third quadrant, reference angles pi over 4. So we have pi over 4 and 5 pi over 4. Happy day. I love these. These are so much fun. But with this one, there's nothing I can really substitute. This could be cosine squared. That's all good and dandy. But this one kind of stops us. So with this double angle, I always look at that one first. So I have 1 minus sine squared already, so I might as well keep everything in terms of sine squared and substitute 1 minus 2 sine squared for it. So if I have 1 minus sine squared minus 1 minus 2 sine squared, almost messed up, equals 1/2. Then I can distribute the negative. So I have 1 minus sine squared minus 1 plus 2 sine squared equals 1/2. Make sure you distribute that negative, please. Then you have 1 minus 1 is 0. Negative sine squared plus sine squared is sine squared. So I have sine squared equals 1/2. Well, look how easy that was. And if you take square root, you have sine theta equals plus or minus. Please do not forget the plus or minus, or half of your answers are gone. And we are sad. Well, that's in every quadrant where we have opposite over hypotenuse to be 1 over root 2, so it's going to be our pi over 4 angle, so theta should be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Yay! Alright, now we're going to get into half angle identities. Notice I know it's a half angle identity here because the angle is being divided in half. So if you tried to calculate this and actually divide the number by 2, you would have cosine of 22.5. But, oh no, we don't have 22.5 degrees on the unit circle, or anywhere in our triangle. So we're going to have to use our identities to calculate this function. Well, lucky me, I have an identity sheet that I can use. Cosine of some angle divided by 2 is plus or minus 1 plus cosine divided by 2. So, plus or minus 1 plus cosine of that angle divided by 2. Lucky me, I know the unit circle of my triangle, so I can evaluate cosine of 45 degrees and say that that is square root 2 over 2 or 1 over square root 2. So 1 plus 1 over root 2 divided by 2. If you write it like that, we'll be happy. Yeah. You may also see problems like this where it says evaluate using a half-angle identity. Well, notice since it says using a half-angle identity, I want this angle in here to be some angle divided by 2. Well, it's easy to set up a problem, so if this needs to be 67.5 is some angle divided by 2, well, hey, oh, that's easy to solve, and I can figure out that that angle up here has to be multiplied by 2 times 2. What is that? 120 plus 15, so 135. 135 equals theta. So all that tells me is that I'm doing sine of 135 degrees divided by 2. And then from there I can use my identity sheet. Sine of some angle divided by 2 is plus or minus the square root of 1 minus cosine of that angle, all over 2. I can evaluate cosine of 135 degrees. Do not forget that 135 degrees is in the second quadrant where cosine is negative. So I have plus or minus 1 minus negative 1 over root 2 because my reference angle is 45. If you're having trouble evaluating trig functions, 4.3. Go look it up. Watch some videos. Figure it out. Come on. So then you have plus or minus square root 1 plus 1 over root 2 divided by 2. There we go. Alright, here's another one just like it. I want this angle to be divided by 2 somehow. So what I'm going to do is take 11 pi over 12, say that this needs to be some angle divided by 2. In order to figure out this angle on top, I can multiply both sides by 2 times 2. 2 divided by 12 is 6, so this is 11 pi over 6 equals theta. And I can say cosine of 11 pi over 6 divided by 2. And it's just a matter of using my identities. Cosine is what, 1 plus? Yeah. So plus or minus square root 1 plus cosine of the angle divided by 2. Cosine of 11 pi over 6, ASTC, is in the fourth quadrant. It is positive. Reference angle is pi over 6. Adjacent to that would be root 3, so 1 plus root 3 over 2. All of it divided by 2 inside the square root with a plus or minus on the outside. Yeah. Boom, money. Alright, last one. So again, just like our double angle identity solving, I can use a half angle identity there. I know that half angle identity for sine is square root of 1 minus cosine all over 2 plus cosine. It's theta, not an e. There. So in order to get rid of the square root, I know I can square both sides. The only problem with squaring both sides right now, if I were to do that, I would have to multiply all of that stuff together twice, and I would end up with some square roots. But if I move over the cosine and just change this into 1 minus cosine theta over 2 equals 1 minus cosine, that is going to make multiplying a lot easier. So that now when I square both sides, I don't have to multiply by that square root. Yes, I will have to multiply 1 minus cosine times 1 minus cosine, but that is a lot easier to multiply than multiplying by a square root twice. So I'm essentially getting rid of that square root on the left-hand side. Divided by 2 equals 1 minus 2 cosine plus cosine squared. And then it's just a matter of solving from there. To get rid of this 2, you can multiply by 2 times 2. Make sure you guys remember how to solve equations. Oh man, it makes me so sad when you can't do Algebra 1 skills. Yay. And then since it's a quadratic function, I'm going to get everything on one side. So I'll subtract 1, and I will subtract 1 plus cosine and plus cosine. And then this side will be 0. I'm going to rearrange it such that everything is in the appropriate position, and it, well, not appropriate, but such that it looks nice. I'm going to rearrange it such that it looks nice. So I'll move it such that I have that term in front, so 2 cosine squared. I know I have negative 3 cosine, and I have plus 1, equals 0. Take a second, make sure you understand where everything went. Everything's still there, nothing went away. Don't tell me it went away, you're crazy. So this will factor. Man, I cannot write cosine today. There we go. Oh yeah. And I remember how to do section 5.3 because I remember how to study and do things that we did in the past. Yeah. Did pi over 3 and 5 pi over 3, and cosine is 1 at 0 pi. Happy day. Hopefully this video was helpful for you guys. I will see you in class, and have a good rest of your day. Yeah. Bye-bye.